Hey, good morning. This is DataFriday, and I am your host, Jean-Georges, or JG Perrin. And today we are having a chat with Guillaume Moutier, and Guillaume is working with Red Hat on this Open Data Hub project. And I'm really excited to learn more about it and to share it with you. So let's get started with Guillaume. Okay, so good morning, Guillaume, and can you introduce yourself a little bit, and then we'll jump into Open Data Hub.
Yeah, good morning, JG. I'm Guillaume Moutier. I'm a technical evangelist at Red Hat in the data services business unit, where I'm taking care mostly of all of what is related to data science platforms and data engineering in general. So all throughout the life cycle of the data, from its ingestion, creation, then to its archiving, with the processing meanwhile, obviously, I'm helping customers and many organizations to deal with all the problems that are related to that.
Okay, that's great. So just as an anecdote, you're French. I've invited quite a few French people. Actually, I have not invited an American person yet on this show. So I've got to do that. I've got a few names in mind. And you're living in Canada. So we're in the same time zone. So
Yeah. I moved to Canada 20 years ago.
Okay, great. So let's jump in and show us what's Open Data Hub is.
Yes. First, let me share my screen. And normally I've prepared just 2 slides just to set the stage, to explain what we are doing at Red Hat with Open Data Hub. We came to the conclusion, by interviewing many people, many data scientists, and talking with various organizations, that in fact what data scientists want is simply to be able to use the tools. Okay, right. They don't want to take care about the infrastructure or everything. Anyway, it's not their main their main skill set. If you are a chemist or a biologist, you can be also a data scientist. Exploring data and trying to find out new patterns or research algorithms and things like that. But you're not an IT people. So maintaining the infrastructure, the underlying infrastructure, and especially at the pace it goes. There is a new framework every month or something like that. So it takes a lot of time just to take care of this part of the problem. So as a conclusion, they only want to have self-service tools, and that's what we are doing with Open Data Hub. Open Data Hub is kind of a mix of various data science tools, Kubeflow, Jupyter, Seldon, Argo, Kafka, all the things that you can use for your data pipelines, or in your data engineering or data science part of your job, but that we have packaged as an easy to deploy set. And for this, we are using Openshift Operators. Okay. Just a quick word. Do you know what operators are?
I know, but I wouldn't mind an official reply and an official answer for it.
Okay. On OpenShift, what operators are doing is exactly the work that experts in a specific application would do to deploy it. Okay, so it's basically taking all this knowledge about how to deploy Kubeflow, or how to deploy MySQL database or any other application, and put all this knowledge into an application, into a package that will take care for you of the deployment, of the upgrade, of the maintenance, every day 1 and day 2 operation that you can think of, so that you only have to use this specific application. Let's, just as you have on an app store, where you just click on the application and bam, it's installed on your phone.
That was the analogy I was thinking about. So basically, you pick and choose what you need, and in the OpenShift world, that's called an operator.
Exactly, and we will see in a few seconds how it works to just say to Open Data Hub, oh, I want to deploy Jupyter and Argo, and bam, in a few minutes later, you have it available for you to use.
And
you don't have to.
And then
to read
it will also take care of the connectivity between these applications. Like I'm just, I've got a little bias for Spark, and I love Jupyter as well. But it's always a mess to connect both of them. At least my level, because sometimes I think I'm like a data scientist, sometimes I think like I'm a data engineer. But the thing is, deploying all these things, I'm the guy that always have all the trouble. So
yeah. That's what we have packaged in Open Data Hub. There is also a Spark operator that will take care for you of deploying Spark and connecting your notebook.
Awesome.
It works like this. Okay, so let's jump into it. I will show you how it works. And so here is the Open Data Hub dashboard. Well, it's a very crude version for the moment. We released it only a few weeks ago, and I didn't mention it. Open Data Hub is not a Red Hat product. It's not something that you can buy. It's a full open source project that you can deploy on any OpenShift cluster. It doesn't have to be a Red Hat OpenShift. It can be the community version. And yes, it's just some kind of a reference architecture or Kickstarter project to help you put up your data science platform in a very fast way. Okay, so you have the Open Data Hub dashboard, and here you can see the different tools that are available in my OpenShift deployment. I have Jupyter Hub, Argo, Superset, and Spark. Those are the tools that are installed. There are many others, almost 10 different data science related tools that you can deploy with Open Data Hub. Okay. But here on my instance, I only chose to deploy those 4 ones. Okay. Let's launch Jupyter Hub. And here, you must bear in mind that's what the most important thing is with Open Data Hub is that as a data scientist, as a practitioner, I didn't have to install anything on my computer. Okay, it's only my web browser where I am connecting to the instance that has been deployed on an OpenShift cluster, and bam, I have access to Jupyter. Here's with the spawner in Jupyter Hub, I can choose between different images of notebooks. Each one has its own, characteristics with different baked-in libraries. And we start first with a small image that has SciPy embedded. Okay, I click on spawn.
So, and these images are provided by you. I mean, when you upgrade to new versions because it's, as you said, it's moving so quickly.
Yeah, there are a few base images that are provided with Open Data Hub, and of course they are updated regularly in the project. But you can also create your own images. You can add some more libraries if you want to use them, or customize in many ways the way your Jupyter environment is working. For example, for a project with a team of researchers in Ontario on COVID-19, they wanted to be able to use R scripts at the same time as Python script, because that's the way they were working. Yeah. So with them, we created a new notebook image that has both libraries, Python and R, baked into the notebook image, so that they are able to do this. Okay.
And so I saw briefly the image was downloaded from Quay. So any image that is on Quay can be used actually, or is
Quay or Docker Hub or anything. You just in the Jupyter Hub configuration, you just point to the different images that you want to use, but it's perfectly up to you. It can be your own registry. Here, the base images that come with the project are hosted on Quay. But if you add more images to your project, and it's only a small configuration in the image that you program on OpenShift, you just a Kubernetes annotation that says this is a notebook image, then it will be picked up by Jupyter Hub and displayed as a choice. Okay, but can come from anywhere. And here to show you how it works, this is a very basic SciPy thing. It's just to show you that it's working. It's not a totally fake show. And here, that's the Easter egg standard from SciPy. Okay, I will close this notebook and I will explain what happens underneath.
Okay.
Here, let me go back. This is my OpenShift environment on my Open Data Hub project. And here, we'll see the pods. Sorry, it takes some time because my lab is in Bangalore, India, and in North America, so it takes some time. And here you can see that those are all the pods, and I will zoom in a little, it will be easier. All the pods that are deployed in the project. And you can see here that there is one, Jupyter Hub notebook, Guillaume Moutier, that's my name, that's my notebook. And this one was spawned automatically when I choose the image and when I clicked on spawn. Okay, this is not something that is running 24/7 compared to solutions based on VMs and things like that. This is totally on the fly spawning of your resources. And
awesome.
we will see it here when I will go to the control panel just to shut down my instance. I will stop my server. And if I go back here, you will see that the pod is terminating.
Wow. Okay. So that's fast. Okay. So
yeah, and it's a very, very efficient use of your resources of your cluster. That means that you can have this platform shared by many data engineers, data scientists, but consuming only what's useful. Because it's not true that everyone is connected all day long, all their work day on the platform and working on the notebook. So as the spawning is fast and the logouts is also very fast, they don't have the need to have those resources consumed from your IT infrastructure all day. Okay. And to the
does it work the other way as well? When for example you need more resources, it scales up.
Well, when you need more resources, you have, unfortunately, to respawn your notebook. And here, let me show you. I will start a new server to explain this. You see here in the deployment size, you can choose between different sizes of the notebook that you want to use. And this is also totally configurable. So you could have a very large, let's say you are working with genomics and you want to have 128 gigabytes of memory and 32 CPUs. That's something you could have here, provided that you have sufficient servers on the cluster for those requests. You can also choose to have GPUs. If your cluster is GPU enabled, then what Kubernetes will do underneath is spawn your pod on the servers which have GPUs instead. Inside. Okay.
So you can train your model with GPUs and
exactly.
Awesome.
So very efficient use of the resources and zero management from the data engineering or data scientist point.
Yep.
Okay. And now I will show you to your question about Spark. Here I have an image that is Spark enabled. Okay, so it means that Spark has been installed within the container image and configured in the right way, and I am able to spawn this new image. And why it spawns, we will go back here and see what happens, and I will filter against my name. And what you are seeing here is that there is a new notebook being created, a Jupyter notebook with my name. That's the Jupyter image itself. But at the same time, and it went faster because the images were already on the node, it has spawned a new Spark cluster, which is now running. Okay, and you can see that this Spark cluster is also identified with my ID. That means that is my own Spark cluster that I can use in conjunction with my notebook.
Yep. Okay.
And we'll go back here. Well, still starting because it's a new image. and it's quite huge. Well, it happens. This is a brand new OpenShift environment, so of course it has to pull down the image from Quay. That happens, the first time it's launched. But afterwards, of course, as these images are already on the OpenShift nodes, it gets much faster. Okay, we'll wait.
So also, as the image is tagged with your name, we know if something is running for too long, we can say, "Hey, Guillaume, take care of your mess, please. Go clean up."
Exactly, and there is even a failsafe configuration inside Jupyter Hub where, you can enable it or not, that's your choice. If a notebook has been running for more than 3 hours without any communication with Jupyter Hub, so that means sitting idle, doing nothing, Jupyter Hub will just kill it. Okay, and that will be the end. Of course, I said 3 hours because this is a standard, but this is totally configurable. So it's pruning automatically the idle notebooks.
And it can start. I mean, we see at which speed it starts. Okay, so it's not something you have to start. I've seen some people starting massive EMR clusters on a Monday morning, running them until Friday after Friday when they leave.
Oh no.
Because it takes time to set up the cluster, right? And so that's the kind of experience I've seen. So I like that.
So here, and you've seen it. It took 30-40 second stop because the notebook image was not on the node, but it gets even faster later on. And I have here my Spark cluster that has been spawned in a few seconds too, and that is ready to use. And well, we'll use it here. I have a small notebook, which is basically, and in fact, I don't even need this. I'm just creating a Spark session, and I'm testing it with only a small configuration here. And you can see that what I am doing here to connect to Spark is a very generic connection string. Okay.
Yeah, and I like that. You just pick up the cluster address from an environment variable, and off you go.
And this environment variable has been automatically populated by the Spark operator at the time this very notebook has been created. Okay, so this is my environment variable. If you were running under your own account, it will be the value would be different and would point to another Spark cluster that will be also alongside. It takes some time here just to connect and create the random thing, but it will come out eventually in a few seconds. And yes, this is what is happening. Is my pod here is communicating with the master here, that's the -m, and the Spark master is working with 2 workers.
Okay.
And of course, and all the commands are run on the worker. Okay, but I didn't have again to make those links in between the notebooks and set up Spark. I don't even know how to set up Spark. And
I can recommend a book.
No, but from a data scientist point of view, I don't care on how to set up Spark.
And you should not. Yeah, exactly.
I want to use it. I want to use it. That's totally different.
Yeah.
Okay. Then again, of course, here I have 2 workers with a specific configuration. This is totally configurable. By the admin, you can choose to have 16 workers, or you could modify, the launch screen to give the ability for the user to choose. Oh, I want to run with 3 workers, 5 workers, whatever. And yes, it's automatically done. Yeah,
and it's in a finite environment because it's in your OpenShift cluster. It's by definition finite, so it's not like it's going. Okay, you can be unnice to your friends using the same cluster, but as is a predefined cluster, your cost is going to be the same cost. It's not going to be like you use, I would say, any open technology where it can scale like crazy, and you don't know the bill until 2 or 3 months later.
Yeah, it's totally fixed here, and it's tagged. So you could, internally, you could even put out some bidding around who's using what, because you know exactly who has spawned which cluster at which size and consuming which resources and everything. So that's a pretty neat way. Usually what people do also is to customize the Jupyter Hub configuration so that, let's say you are a trainee, you only have the right to spawn very small notebooks, and maybe with Spark with only one worker, because, okay, that's enough for your job. If you are the head of the data science team, then maybe you are allowed to launch much bigger notebooks with huge Spark clusters. And this is what would appear in your configuration, when you are choosing the image and everything.
Okay, yeah.
And here it has finished. And we can see that we are connected to the Spark cluster with those two workers.
Okay, yeah. That works.
Well, took some time. It was my first connection. And in fact, the time it took is that it had this notebook, as it was a brand new environment. It had to download, all the Java packages.
Oh yeah,
you know it works with Spark. It's downloading all the Java packages inside my own environment. This is something I didn't mention here. With my notebooks and everything, this is my own environment. When you are launching a new Jupyter environment, when it's brand new, what is happening is that Open Data Hub, Jupyter Hub is creating a persistent volume for you, to hold all your files. When you shut it down, this persistent volume, of course, is disconnected because the container does not exist anymore. But when you are relaunching a new container, it is reconnected automatically to your own volume. So it's your pure environment that is only for you, and that's where it has also downloaded all the Java packages.
So that was actually one of my questions I had. So thank you for answering it without me asking. But that's pretty impressive. And you can still connect your notebook to GitHub or whatever to do some source control on your notebooks as well.
Oh yeah. And here, maybe this would be for next session of DataFriday, but we have newer releases with with new customized notebooks that include, for example, Elvira. Elvira was developed by IBM. It's also an open source project. It's an extension to Jupyter with lots of very interesting functions, like this one, to connect directly to GitHub to version control your notebooks. It has also other tools to create pipelines. You create your notebooks, and graphically you can create your pipelines using those different notebooks. Lots of very interesting things, but definitely all the notebooks extension that exist you could install and use inside your environment.
Well, Guillaume, that was we tried to keep it short and sweet. That was really impressive. I really like that. I really like the overall easiness of using all that, and it's indeed for me it's great. So thank you for joining us, and you tempted me. You're welcome anytime on the show, and I think there's a few things we need to discover and learn from each other. So Guillaume, thank you very much. À bientôt.
Thank you for having me.
And have a great weekend. Bye bye.
Bye bye.